Okay children, in this video we are going to study about the venation and phyllotaxy. First let's understand what is venation. The arrangement of the veins and veinlets in a leaf blade or a lamina is called as the venation. So in different leaves you can find different types of veins or vein arrangements can be seen. So this arrangement of the veins and veinlets in a leaf blade or a lamina is called as the venation. In these veins only the vascular tissues, that is the xylem and the phloem, are present. Now conventionally, venation is classified into two types. From the olden days, this venation is being classified into two types. They are the reticulate venation and the parallel venation. Now what is this reticulate venation? From the midrib, the veins they arise and the veins give rise to the veinlets. These veins and the veinlets they intersect each other and they form a network-like structure. Reticulate means network. Network-like structure. This is called as the reticulate venation. In parallel venation, it is the from the midrib the veins arise, and these veins they run parallel to each other. They do not intersect. They run parallel to each other from the midrib to the leaf margin. Then it is called as the parallel venation. Okay, this reticulate venation is the characteristic features of the dicot plants, whereas the parallel venation is the characteristic feature of the monocot plants. So let's first study about the reticulate venation in detail. A reticulate venation, in this type of venation, a leaf contains a prominent midrib from which several secondary veins arise that branch and anastomose like a network. So that is what I said. The veins which arises from the midrib, they further branches and they intersect each other to form a network-like structure. Then it is called as the reticulate venation. This type of venation is common in all dicot leaves. Reticulate venation is common in the dicot plants. There are two types of reticulate venation. Reticulate venation is further classified into two types: pinnately reticulate venation and palmately reticulate venation. So here, pinnately reticulate venation, it is called as the unicostate. So here, in this type of venation, there is only one major midrib in the center, which forms many lateral branches to form a network. Example, Mangifera indica. So here it is pinnately. Pinna means a pinna of a bird, you can imagine. So here you can see in this diagram, figure 3.12, the A diagram ficus. So here you can see only one major midrib is present in the center. From there, easily visible, the veins are seen there. Okay, this type of arrangement, it is called as this type of vein arrangement in the leaves, it is called as pinnately reticulate venation, that is formed on major midrib. From there, in the side, the lateral veins are arising. Then it is called as pinnately reticulate venation. Next is the palmately reticulate venation. In the palmately reticulate venation, it is also called as multicostate. Now here in this the venation, there are two or more principal veins arising from a single point and they proceed outward or upwards. So here you can see in this diagram in the cucurbita, the B diagram, you can see the cucurbita, 7 center midrib is there. From the point, one point that is near to from where the petiole is arising and joining the leaf lamina, in that point you can see from that particular point numerous main veins are arising. From one point in the midrib, numerous main veins arise. They then further produces the veinlets. Similarly, in the upward direction also you can see numerous veins. They arise from a midrib, from one point in the midrib, and they run outwards or they move upwards. Then it is called as the palmately reticulate venation. This palmately reticulate venation, you can compare it like a palm. Okay, now here they are of two types. They are divergent type and the convergent type. Divergent type, when all the principal veins originate from the base and diverge from one another towards the margin of the leaf. as you can see, carica papaya. So here you can find that is from one point on the midrib there are numerous veins are rising and they all run to the leaf margin. Okay, that is they are moving outwards. This is called as the divergent type. Whereas in the next type of palmately reticulate venation, convergent, when the veins they converge to the apex of the leaf as in the Indian plum or that is Zyzippus or bay leaf. So here you can see here also from the major midrib the veins are arising. These veins they come and meet to the they move towards the apex of the leaf. They are coming and meeting in a point. Then this type is called as the convergent type. So palmately reticulate venation, they are of two types. They are the divergent type and the convergent. If the veins they originate from the midrib and they run towards the periphery, towards the margin of the leaf, then it is called as divergent. When the veins they originate from one point in the midrib and they grow upward towards the apex of the leaf or they come and meet towards the apex of the leaf, then it is called as the convergent type. So these are the two types of reticulate venation. Next we are going to study about the parallel venation. Now parallel venation, the veins they run parallel and they do not form a prominent reticulum. So here as we have said, from the major midrib the veins originate. These veins from the midrib they run towards the margin and these veins they do not intersect each other, so they are not forming a network like structure. This is called as the parallel venation. It is a characteristic feature of the monocot leaves. Now parallel venation is also of two types. They are pinnately parallel venation and next palmately parallel venation. Pinnately parallel venation is called as unicostate, palmately parallel venation multicostate. Now, when there is a prominent midrib in the center from which arise many veins perpendicular and run parallel to each other, example Musa, ginger. So, here we have seen all of us seen as the banana leaf. In the banana leaf, there is one major center midrib is present there. From that major midrib, you can see the veins are arising and these veins they run they are perpendicular to the midrib. The veins they are perpendicular to the midrib and they run to the end of the margin. Okay, they from the midrib they go towards the margin. This type of arrangement it is called as the pinnately parallel venation or it is also called as unicostate. Now, palmate parallel venation in this type, several veins arise from the tip of the petiole and they all run parallel to each other and unite at the apex. It is of two types, divergent type and convergent type. Next is the palmately parallel venation. In the palmately parallel venation, from the um, uh, point where the petiole joins with the lamina, from there numerous veins arise, and these veins they are traveling in such a way that they come and meet in the apex. So numerous veins arise from the base of and merged in the apex, then it is called as the divergent type. So here you can see in this diagram here, so C diagram figure 3.13, in the C diagram you can see the petiole where it joins with the leaf lamina. From that point numerous uh, veins are arising and these veins they are running uh, parallel to each other. Okay, then it is called as the divergent type. In the B diagram you can see in the bamboo, this is the convergent type, that is from the leaf base the numerous veins they arise, they run parallel to each other and they come and join in the apex. Okay, they are not they are just coming and reaching towards the apex. This is called as the this is called as the convergent type. So here we have seen there are palmately parallel venation, two types are there, divergent type, convergent type. So all principal veins originate from the base and diverge towards the margin of the leaf as in a fan palm, then it is called as the divergent type. Convergent type, all the principal veins they run parallel to each other from the base of the lamina and join at the apex as in bamboos, rice, water hyacinth, etc. Then it is called as the convergent type. So here you can see in this diagram, you can find here the types of parallel venation. First one we have studied, only one major midrib is there, and from that major midrib numerous uh, uh, veins are arising, they are parallel to each other. The example you can find in the canna plant. Next in the B and C diagram, they are representing the palmately parallel venation. So B diagram here you can find from the leaf base, the numerous veins are arising which are parallel to each other and they go towards the apex. So this is called as the convergent type of palmately parallel venation. Next is the C diagram is the borassus. From the leaf base you can see numerous veins they are arising, and these veins they are parallel to each other and they are growing from the leaf base towards the leaf margin. Then as a result it is giving a fan like appearance to the leaf. This is called as the divergent type of palmately parallel venation. Next, we are going to study about the phyllotaxy. Phyllotaxy means the arrangement of the leaves in a plant. Okay, arrangement of leaves in a stem of a plant is called as phyllotaxy. Phylos means leaf, taxus means arrangement. Now, why the phyllotaxy or arrangement of the leaves is different in the plants? It is to expose the leaf to get the maximum sunlight. If this particular arrangement is not seen in the plant, what will happen? The leaves will be overcrowded and the leaves will not able to trap the maximum sunlight. So phyllotaxy is to avoid the overcrowding of leaves and expose the leaves maximum to the sunlight for photosynthesis. The four main types of phyllotaxy are alternate, opposite, ternate and whorl. So in the plants you can find basically four types of phyllotaxy: alternate, opposite, ternate and whorl. So here just I explain you. Alternate means, as we know, the leaves are arising from the stem in the nodes. If in a node only one leaf is present, okay, and in the next node another leaf is present, but both the leaves they are arranged in opposite direction, then it is called as the alternate. Opposite is what? In one node, two leaves arise in the opposite direction. Then it is called as opposite. Alternate we said, in one node, one leaf. Opposite, in one node, two leaves. Ternate means in one node we have three leaves. Okay, the three leaves originate from one node, then it is called as the ternate venation. And the whorl is more than three leaves originate from a node, then it is called as the whorl phyllotaxy. So first we will study about the alternate phyllotaxy. In this type, there is only one leaf per node and the leaves on the successive nodes are arranged alternate to each other. Spiral arrangement of the leaves they show vertical rows are called as orthostitches. They are of two types. So alternate phyllotaxy we have studied. In one node only one leaf is present. In the successive node, that is in the next node just above it, the another leaf will be present, but the arrangement of both the leaves will be in opposite direction. So here in the spiral arrangement, when the leaves are arranged spirally, then they are of two types. They are alternate spiral and alternate disticus. So alternate spiral means in which the leaves are arranged alternatively in a spiral manner. Spiral means you can imagine like a spring. So just in a spring pattern, okay. So numerous leaves are arranged in that spring pattern in different nodes. Then it is called as alternate spiral. Alternate disticus or bifarious, in which the leaves are organized alternatively in two rows on either side of the stem. Disticus means the leaves are present in two sides of the stem. Okay, so here we can say that is in two direction, we'll see north and south direction. First node the leaf is present towards the north direction. Another node, the successive node, will find the leaf is present in the south direction. Again in the next successive node the leaf will be present in the north direction. That is, the leaves are present only in two rows, okay, but alternatively, then it is called as alternate disticus. Whereas in alternate spiral, you can find the leaves will be present in all the directions. North, then it will be northeast, then it will be towards the west, sorry, east, then towards the uh, northwest. Okay, so here in each direction you can find, in all the 8 directions you can find the leaves are arranged, then we can find it is called as the alternate spiral. So here we can see in the diagram polyalthia. So this is an example for alternate distichus. So here you can find that is in one node one leaf is present in one direction, another node another leaf is present both in the different directions. Then this is an alternate phyllotaxy, but in alternate phyllotaxy we will say it is the alternate distichus. Next type of phyllotaxy is the opposite. In this type, each node they possess two leaves opposite to each other. They are organized in two different ways: opposite superpose and opposite decussate. So, opposite phyllotaxy, as I told you, in one node two leaves are present, but in the opposite direction. They are of also two types: opposite superpose and opposite decussate. The pair of leaves arranged in succession are in the same direction. That is, two opposite leaves are at a node lie exactly above those of the lower node. Example: cedium, quiscalis. Okay. Next is the cedium is the example, that is the guava plant. Next, opposite decussate. In this type of phyllotaxy, one pair of leaves is placed in a right angle to the next pair of lower leaves, upper or lower leaves. Then it is called as the opposite decussate. So it is in the calotropis or ocimum. So here you can see in this diagram here. So opposite decussate, the two diagrams is given. So here in the first one you can see that is in one node two leaves are present, in the next node also two leaves are present. So this arrangement we call it as opposite. Now here you can see in the first opposite phyllotaxy that all the leaves they are arranged in the same direction. Okay, that means the leaves they are place one above the array, another, but in successive nodes. Then this is called as opposite superposed. Example we have studied, it is the guava plant. So this is the opposite superposed. Example is the guava plant. Next you can see in the opposite decussate, in one node the leaf is present in one direction. In the successive upper node, the leaf is present at the right angle to the previous one. Then this is called as the opposite decussate. So here you can see in the in the lowest node, suppose if we say it is in the north south direction, next in the successive node the leaf will be present in the east west direction. So this is called as the opposite decussate. Example for this opposite decussate is the calotropis. Next, the third type of phyllotaxy, it is the ternate. In this type, there are three leaves attached at a node. Example, nerium. So here you can find in this direction, in this diagram, that is in one node, three leaves are arising. Then it is called as the ternate. Example for ternate phyllotaxy is nerium. Next is the walled or verticillate types of phyllotaxy. In this type, more than three leaves are present in a wall at each node, forming a circle or wall appearance. Then it is called as walled. Example is alamanda. So here you can see here in walled or alamanda, from one node four leaves are arising. Now this is called as the walled phyllotaxy. So here we have studied about the four types of phyllotaxy. That is, we have studied alternate, opposite, ternate and walled. Next we are going to study about the leaf mosaic. In leaf mosaic, leaves tend to fit it in with one another and adjust themselves in such a way that they may secure the maximum amount of sunlight with minimum amount of overlapping. The lower leaves have longer petioles and the successive upper leaves they possess shorter petioles. So this is the another arrangement you can find in the leaves, it is present there. The leaves are arranged in such a way that is they should get the maximum sunlight and the overlapping should be less. So for this the lower leaves will be the lower leaves will be having a longer petiole, whereas the successive successive upper leaves they will be having the shorter petioles. Example, it is the acalifa. So with this we have completed today's topic. In the next class we will study about the next topics of the leaves. Thank you, children.